In this topic, we will be working with formulas and basic geometry. It is the first of several concepts in which we actually get to apply the linear equations that we just learned how to solve. The first thing we need to do to start this section is we need to review some basic shapes from geometry, namely the triangle, the rectangle, and the circle. Now there are two concepts that apply to the triangle, rectangle, and circle, the perimeter and the area. Now recall that the perimeter of a triangle or any shape is the distance around the outside. So specifically on the triangle, it's the distance around the three sides, which you can obtain by adding them up. So the perimeter of a triangle is A plus B plus C. The perimeter of a rectangle, likewise, is also the distance around the outside. There are four sides this time that you're going to add up. There's going to be two lengths and two widths. And then the perimeter of a circle, well, we give it a special name. The perimeter of a circle is called the circumference of a circle. The circumference of a circle, or the perimeter of the circle, is the distance around the outside of the circle. Now, unlike a shape that has linear sides, the circle we get, the circumference of a circle we get by applying a special formula, 2 times pi times r, where r stands for the radius, which is the distance from the center of the circle to any point on the circle. Also recall that pi is the Greek symbol that we use to approximate the irrational number that goes forever and ever and ever. We use the approximation of pi being 3.14. The other thing we need to remember is the area formula for each of these shapes. The area of a triangle represents the shaded part inside the triangle. To calculate the area of a triangle, you take 1/2 times the base times the height. To calculate the area of a rectangle, or the shaded part within the rectangle, you take the length times the width. And to calculate the area of a circle, the shaded part within the circle, you'd use the formula area equals pi times r squared. Again, where pi is that irrational number, which we approximate with 3.14, and r is our radius. Now, as we begin these application problems, one of the first things you want to do is you want to make sure that you draw a picture, because when you draw a picture, you'll get a visual representation and it'll make solving the problems much easier. We are now ready to begin looking at application problems that pertain to geometry. So let's start with example 1. Example 1 reads, the perimeter of a rectangle is 66 inches. The width of the rectangle is 3 inches less than the length. Find the length and the width of the rectangle. All right, what we want to do first, anytime you encounter a geometry problem, at least what I would suggest, is that you draw a diagram or a picture that pertains to the problem. This helps us to visualize it and write the equation. So let's start by drawing the appropriate picture for this problem, that is a rectangle. Cool. The second thing you want to do is determine what it is that you're looking for. That is, what is the problem asking you to find? And in this case, and generally every case, it's the last sentence of your problem. It says find the length and the width of the rectangle. So it's asking us to find two things. So let's go ahead and label our rectangle with L for length, because we don't know what that is and we're looking for it, and W for width, because we're also looking for that one as well. Now, let's look at the first sentence in the problem and see what we can do. The perimeter of a rectangle is 66 inches. This means the perimeter is going to be somehow involved in this problem. And we have a formula for the perimeter of a rectangle. We just talked about that earlier. The perimeter of a rectangle is 2 lengths plus 2 widths. Or in other words, the distance around the exterior of that rectangle, 2 lengths plus 2 widths. Remember that? Now in this problem, it tells us specifically that our perimeter is 66 inches. So that means that 2 lengths plus 2 widths has to equal 66. So that's going to create our math equation that we're going to work with. 2L plus 2W equals 66. Now the second sentence in this problem, the width of the rectangle is 3 inches less than the length. This gives us another math equation that we're going to work with. The width of the rectangle, so that means width is W, is 3 inches less than the length. So I'm going to put it over here by my rectangle because it's corresponding the width and the length. And the expression is that the width is 3 inches less than the length, or length minus 3. So W is length minus 3. Width is 3 inches less than the length. In order to solve our equation over here, what we'd like to do is get a single variable. Right now we have the L and the W. But we can now use this little relationship over here to replace our W with L minus 3 in this equation, and then that will make an equation with just one variable. So let me do that. In place of the W, we're going to replace it with the formula or the expression L minus 3. So let's do that. So in place of width, we now have L minus 3, but more importantly, we now have an equation which has a single variable L, and we can solve this equation using the techniques that we learned in our last module about solving linear equations. What do we do to start? We simplify each side. So that means we're going to simplify the left side by applying the distributive property here, taking the 2 and multiplying it through. Doing so will give us the following equation. 2L plus 2L minus 6 equals 66. We continue simplifying the left side. We're going to put our like terms together, the 2 L's together, and that's going to give us the next step. 4L minus 6 equals 66. At this point, if you're really thinking, you notice that each term is divisible by 2, and you could divide each term by 2 and make a smaller equation, but most students don't see that. So we'll continue carrying on. I will rapidly write the next few steps to the solution to this equation. I think you guys can follow along and do it on your own too. And let's see what result we get. Adding 6 to both sides, you get 4L is 72. Dividing both sides by 4. We get the final answer, let me change color here, of L equals 18. And remember, the L represents the length, which is a measurement. In fact, it's a measurement in terms of inches. So our length is 18 inches. Finish the problem now by going back and finding the width. The width of our rectangle, if you recall, is 3 inches less than the length. Because our length is 18, that means our width is 18 minus 3, or 15. So let's write width is 15 inches. Perfect. Let's take a look at example 2. Example 2 reads, the diameter of the circular Georgia Superdome Stadium is approximately 840 feet. Find the area enclosed by this circular dome. So, as before, let's start by drawing a diagram. And in this case, the diagram we want to draw, the picture we want to draw, is a circle to correspond to the circular dome. So we draw a circle. Now let's label this circle with the appropriate diameter. The diameter is 840 feet, and recalling that the diameter is the distance across the circle, the whole way across, so that means the whole way across this circle is 840 feet. Now, what is it that we're trying to find? Look at the last sentence of the problem. We're trying to find the area enclosed by this circular dome. But we know the formula for the area of a circle. We talked about that a minute ago, or 2 minutes ago, or a little bit ago. The area of a circle is pi times r squared, where r is the radius of the circle. Oh, so that tells me we have to do one more thing over here with our circle diagram. We're given the diameter, which is the whole distance across, 840 feet. What we want is the radius, which is halfway across, the distance from the center to any point on the circle. So the first thing we need to do is we actually need to calculate what that would be, and the radius is just going to be half the diameter. So that tells me that the radius of this circle is 420 feet. And we are good to go and find the area of this problem. All we're going to need to do is substitute the radius, 420 feet, into our formula and solve for our area. Area is pi times our radius, which we just calculated as 420 feet squared. Now, this is where you pull out your calculator, or you pull out a scratch paper and you do the math, but to save time I already did this. So 420 squared we simplify as 176,400. So that means the area of the Georgia's Superdome Stadium is approximately pi times 176,400 square feet. Now, that is the exact area. Doesn't make a whole lot of sense to us if we're telling somebody, oh, the area is pi times 176,400 square feet. So if you want, you can actually find the approximation, and remember to do that. We're going to approximate pi with the decimal 3.14. And so if you take 3.14 times 176,400, you get that the area of that stadium is approximately, and again, I did this ahead of time, 553,896 square feet. Perfect. That answers our question. We box it, and we're done. We are now ready to do our last example, example 3. It reads, find the measure of an angle whose supplement is 8 times its measure. To start, like before, we want to start with a diagram. And in this case, we're also going to do some discussion as we draw this diagram. I'm going to begin by drawing 2 angles, and I'm putting them side by side on purpose, because the definition of 2 angles that are supplementary is that when you put them back to back, side by side, they form a straight line angle. Or, better yet, the measures of 2 angles that are supplementary add up to give you 180 degrees. So here we have 2 angles, which when put side by side, form a straight angle. In other words, the sum of their measures is 180 degrees. Let's take a look at the problem again. What is it that we're actually specifically looking for? We're looking to find the measure of an angle whose supplement is 8 times its measure, but specifically we're looking for the measure of an angle. So one of these angles, let's start by labeling with a variable. I'm just going to choose x because that's our universal variable. That's the measure of this angle is x. And what does the problem tell us? The problem tells us that the supplement, this other angle on the other side that gives us 180 when we add its measure to the measure of angle x, this angle over here is 8 times its measure. And how can we write that? We can write that as 8x. So this angle here, the supplementary angle, is 8x, and the other one is x. This is all the information we need to actually write the equation that will solve this problem. Find the measure of an angle whose supplement is 8 times its measure. What do we know about our picture? We know in our picture that the measure of angle x plus the measure of angle 8x adds up to give us 180 degrees because those 2 angles are supplementary. And that's the equation we need. Now we can finish by solving, and I'm going to quickly go through this. I don't think we need too much practice with solving. You guys should be experts by now, but you get 9x equals 180 degrees, dividing both sides by 9 and canceling. That's going to tell us that x is 20 degrees. So the measure of an angle whose supplement is 8 times its measure would be an angle whose measure is 20 degrees.